Thank you. So, my name is Robert Forsström. I'm the Java Enterprise Platform Architect at Volvo Car Corporation in Gothenburg. In this presentation, I will talk about our runtime platform, how we have transformed it to become more of a platform where you can run microservices, going from huge monolithic Java applications. So, this is our current environment. I'm responsible for providing Java EE to our internal customers. We have 785 applications running on 560 application servers, all on 80 physical hosts. So, this was how our environment looked a year ago. We were running SUSE Enterprise Linux, a Java EE application server called WebSphere Application Server Network Deployment. On top of that, we had a network deployment clustering. So we were providing our services as high available services with service in 2 different data centers. So we had to create a cluster between them, and then we had a couple of application servers and a number of air files in them, depending on how many applications a project needed. We've been doing this for over a decade. But there was a bit of a problem with our platform. Our customer base grew over the years. We started having problems getting service windows for our application server platform. We also started getting requirements for low latency connections globally. That means going to the cloud. We couldn't do that with our platform because we required virtual networks. We had specific things that we built our platform on, and those weren't available to us in the cloud. Our platform was a bit complex getting into place. Sometimes we had to get people drilling holes in our server rooms, getting new fiber cables in place, and so on. So it took ages, and it was a hefty cost to get our platform running the next version. So when we were always a couple of versions behind, so our developers were always using not the latest and greatest technology, but technology that was new 3 years ago. And so we were running our platform, and all of a sudden we started getting things like end of support notifications from our different vendors. And that made us, so then we definitely had to create the new version of our platform. That meant that it was a bit of a panic moment when everybody had to move from the current platform to the next platform. Our platform had to be up and running almost 24/7 because sometimes the manufacturing plants had to be up and running during the weekends because we were running late with different car models. It had to be up and running when on Sunday evenings when our Japanese customers were waking up on Monday morning, bringing their cars to the workshop. So we had to be up 24/7. The problem was also that we built everything on normal hardware. So we couldn't guarantee that our test environment was equal to our QA environment, that was equal to our production environment. Because things change over time. There were incidents. All large organizations have incidents. And that means that there would be fixes into production that didn't come down to the QA environment. So we couldn't really verify that the exact same setup was in QA as in production. So we started the work of designing the new platform. These were bullet points for the new platform. Always offer the latest version of Java and Java EE. our customers, our developers, our internal developers, they wanted to play with the latest technology, but we weren't allowing them. So one of the things was that we were going to give them the latest stuff when it was released. We had to go to the cloud and also into our manufacturing plants all over the world. We wanted to offer isolation, immutability, and idempotency. So we wanted to isolate the application, so a misbehaving application wouldn't cause issues with other applications running on the same host. Immutability. Nothing was to be changed. Once you built your artifact, your application, in the dev environment, you weren't allowed to change that artifact. It was going to be the same artifact in test, QA, production, and even on different cloud sites worldwide. Idempotency. For the things, idempotency is a mathematical term, meaning that if I run the same function a number of times, it will always produce the same result. And we're using that principle with our infrastructure. We always define everything as code. So, for instance, if I define that I want a file in this place, the script will have a look. Is the file there? Yes, it's there. Is it the same checksum? Is it exactly the same as this one? Yes. Okay, I won't do anything. If there's a difference, okay, then I'll replace that file with something else. So that's basically idempotency. You define a state that you want, and the script's mission is to make that happen. So, our first draft was virtual machines. Instead of giving our customers application servers on shared hardware, we wanted to offer environments that were rebuilt from scratch every time they're deployed. I'll get to questions at the end. This would solve a number of issues that we had. We would have isolated environment. We would deploy everything into the cloud. We could run different versions of the application server at the same time. It wouldn't solve the issue with configuration drifting over time. The only time that we would be absolutely certain that the configuration is exactly as you specified it is directly after you provision the server. After an incident or some random maintenance work, you wouldn't be able to define the state of your servers. And the operations cost from going from 80 physical to 850 virtual operating system was too much. We had to find another way. Well, we were looking ahead a bit as well. So we think that Devops is going to come, and it probably will bring in microservices as well into our stack. And we got huge monolithic Java applications that we have put hundreds of years of development, man-years of development into. And obviously you want to break them up, those applications that have the requirement to be in the cloud, that can use microservices. We want to offer a platform where they can start breaking up their application. So we want to give them something that they are used to. So I'll come back to the DevOps and microservices bit a bit later. Our second draft is containers. We have the possibility to automate everything. We have isolated environments. We can run different versions of Java. We use less of hardware, and the configuration is known at all times. This was pretty much the way forward. So we have a small virtualization layer, the container layer, and then we're running the Java EE application servers. Given that the containers are using the same operating system instance as on the physical or virtual hardware or operating system, we don't really have to patch the things that are the underlying hardware as you would have had to do when going to a virtual environment with multiple VMs. but we do have to control what's in the container because those things can be nasty. So we always build our own containers from scratch. We don't allow people to grab a container outside the organization and run it inside right now, because we can't guarantee what's in there. So we're using a product from Red Hat that is called OpenShift. OpenShift is where we build, distribute, and run our containers in. We use it as well to distribute our applications into the cloud. So whatever is working on-premise is just to take that piece, that container, bring it out to the cloud, and it will run exactly the same way as it would, as it's doing right now inside our data center. It's been designed with the developer in mind, but we won't give our developers access to it, because we got nice APIs that we can use to create self-service to it. So we're actually using RESTful services in JSON to create a small portal. And the reason for us using a portal and not just give them the user interface for the runtime platform is that we got other things going on as well. For instance, configuration of load balancers and so on. So we want to provide another way where we can actually invoke those things. OpenShift also allows us to start using microservices. It's got a concept of projects where you have namespaces and like a virtualized network inside it. So if I have a small piece of Java application running inside it, I can actually expose that as a service, and that service will only be available inside that project or namespace. So I can bring in my application into the solution and then slowly break it apart, and that won't affect anything outside it, because that piece, the project, will deliver the same functionality out. We're also using a product called Ansible Tower. We wanted to automate everything, and we succeeded. Nobody has to log into the servers. It's the one that allows us to be idempotent. So we define states. We define that we want a number of servers inside, for instance, Azure North America. It will be running OpenShift, and we are running these kind of applications there. Just get the parameters correct, press a button, and it will actually go out, allocate the servers for us, install all of the basic stuff, grab the application, bring it over to the cloud site, and install it there. Same here, we got nice APIs that we can use for our self-service portal. And we also use it to create and manage components outside OpenShift. So this is where we got the load balancer configuration, setting up new storage, and those kind of things. And we also use it to manage OpenShift, so setting up new projects, adding new customers to our runtime platform. So our new environment looks a bit like this. So instead of going for the whole vast network deployment cluster, we actually have a new one where OpenShift is providing the clustering capabilities. Inside OpenShift, we're running Docker. It doesn't really matter which container engine that OpenShift has. And then we're running WebSphere Liberty Profile in it. So Liberty Profile is an application server that is not monolithic. It consists of a number of modules. So you only load the modules that you need. So I had to go off to Hersley to talk to IBM to get them to support this on Docker, which they did. Otherwise, this would have been a showstopper for our project. So this is good. This is good from an operational part. It's a nice solution. We can grow with it. We can deploy our stuff everywhere in the cloud and on different continents all over the world. But if I put on my developer's hat, what's the difference? Well, there's a couple of things. There's a Java EE version change between the vast network deployment and Liberty Profile. Liberty Profile is running the latest and greatest Java EE, which has removed a couple of technologies that are set to optional, so they've chosen not to implement them. But otherwise, it's pretty much the same. But we wanted to change that. So I've actually started looking into how can make this platform easier for the developer. So started designing it for our developers. So a developer checks in hello world.java to our Subversion and Git or Git, which is then pulled up by Jenkins. Jenkins creates an artifact, hello.air, that is then pushed into a glorified FTP server called Artifactory. The developer takes the air file down to the computer, creates a deploy package. A deploy package is basically a zip file containing your air file. The air file is what you install in a Java EE environment, and a configuration file. The configuration file contains information about, for instance, which databases you're using, which MQQs you're supposed to connect to, what other kind of services that your application needs. Put them on a network file system called a drop zone area. For testing QA, that is automatically deployed through a number of scripts. But for production, we actually have an ops guy pressing a couple of buttons. And we just want to remove all of the operational guys. Not because we hate them, it's because we want them to deliver the value higher up in the stack. We don't want them pressing buttons and going into consoles and doing those kind of things. We want to get rid of those things. So this is how it looks now. The developer checks in hello world.java, and it's pretty much the same thing until we get down there. So we start building the image. We get one artifact. The artifact will never change from this moment. It will automatically be deployed into test. And instead of deploying to QA, we're actually promoting to QA because we're using the same entity that we created in the build step to the QA environment and then to the production environment. This means that we can guarantee that it's exactly the same code, it's exactly the same application server version that is used everywhere within that application version's environments. Because what we had here in the whole environment was basically a possibility that the developer made a couple of typos in the deploy package and maybe actually included a couple of other files like configuration properties file into the deploy package. That meant that we would have different things going to different environments. But we also wanted to have the possibility for developers to define things like in QA, I want to go to the QA database, and into production, I want to go to the production database. So we started looking into templating. So what we actually do is before we start up the application server, the actual thing that will service our users, we will go through and look for different templates. And we'll set all of those things like database, URLs, database passwords, and so on as environment variables. And then we will look through all of the files and look for the template files, and then we'll do a replace for that. So everything, because we don't want to get all of the environment-specific information inside the image because it wouldn't be immutable, because we couldn't bring it all the way through the different environments. And if I needed to change the database password in production, then we had to create a new image over here. So we want to have environment-specific values for that. The build process is basically us in the platform team. We take the latest version of the application server and creates an image for that. And the development team is using an IR file and a configuration file, which they're supplying to us through Artifactory. And the only thing we do within the container build process is to take the artifact from Artifactory, combine that with our application server image, which always going to be the latest version. It's always going to be the latest fix packs. And given that this image is the one that's going through test QA production, that means that we'll have regression testing for every release that we're doing for that new version. And we won't get arguments like, I don't have time to do testing. If we want to upgrade our platform to a new fix pack level, we won't get that argument that we don't have time to test right now, because we're always supplying them with the latest fix pack levels. So it's more secure, it's better, and more stable. So we also wanted to go to cloud, which was dead easy, because we had done our virtualization on containers, and we had a container runtime platform, the OpenShift one. And we had our environment, we had our images built on premise. The only thing we had to do was to set up a new cloud site, which we did using Ansible with the scripts, define that environment, and then push the image to that registry. The Docker registry is basically where you store all your images, container images, and then push it out and start using it out there. So it's really easy. And the only thing we have to do to expand to a new site is to install the OpenShift runtime platform, add it to our self-service portal, and that's it. We're up and running. To summarize, we built our new platform on OpenShift. We're using Microsoft Azure as a cloud provider. Everything has been automated using Ansible. And we're running WebSphere Liberty Profile as our application server platform. In the future, we might expand and also include other application servers into this. So, is there any questions? Yeah.
How long time did this process take?
About a year. So we got the platform there. It didn't take that long to actually get the first versions of the platform up and running. But then you start thinking about things like how we're going to lifecycle manage the platform and start onboarding applications. And for the application, it was a matter of needing to take the code base and going from Java EE 6 to Java EE 7. So that I had to do a couple of changes in the code base as well. Yep.
You didn't have a cost or a time as one of the factors for driving of the change. But I guess it has some benefits on that. And how much would you say you shorten your lead time? How much is it different in cost for your environment?
Well, yeah, from a license perspective, there's a smaller cost for this platform, mainly because of the IBM components. For time, we haven't really calculated. Well, there's a huge time saving for our projects. We haven't really calculated that into money, but now they're allowed to do everything by themselves. They don't have to involve the operations guys to do production deploys, which is really good.
And from an environment point of view, then you said the license cost, but do you know about how much different is it? Is it the same cost as before, or is it cheaper what you have now?
It's cheaper than the old environment. Yeah.
So that from environment perspective, you're basically saving a lot of time and space, I guess, by just using everything within the code down to one test and QA and then direct into production?
Well, what we can do is,
To use different.
well, yeah. Well, I showed a simplified version, because our real one, it's basically what you can do is multiple dev environments, and then you can promote from multiple dev environments into multiple QA environments. You can even have multiple production instances, and then you can test your application before you actually let on any of the users to it. You can dry run your application, and you can also we haven't tried it, but we know it works well. We tried it in test, but we haven't done any production ones with it. You can actually do that. Some of the users are going to the new version of your application, and some of the users are going to the old versions of the applications, which is a good thing. So we can do all of those things.
It's a smart A/B test.
Yeah. And rollbacks are really easy as well, because everything is in an image. I'm not talking about the database changes because, we're not including those in our scope for the application server platform. But when it comes to application server, it's just a matter of a couple of clicks, then you're back to the old version of the application server. Yeah. Okay. Yeah.
How many people were involved in this?
Oh yeah, the people. That's an interesting question, because we had to build this. We had to build the whole environment, and we started looking into what competence do we need to build this. Do we need traditional operation guys? No. Do we need developers? Maybe. So we actually started looking for people that were both operation guys and developers at the same time. They needed to know what development was, and we wanted them to develop scripts and those kind of things. So actually I had 4 people involved in this, 1 project leader, me as an architect, and then Scrum Master and GUI developer, combined role, and 2 guys that was into both development and operations. So we've actually found 2 resources. We started out with a couple of consultants from Red Hat as well, just to get us started with the first version of the platform. And but now we're doing everything ourselves.
But actually, Mark's presentation. So, how do you fit? If you listen to how Mark was telling about the culture and cultural changes and so forth, was it resonating to your
well,
business?
we're actually we don't have to change the culture right now.
All right.
We're moving to the key is exactly the same way that they're used to working. They don't have to change. We want them to change, but they don't have to right now. Because we can move their application into a platform where they can grow and start splitting up their application. And when that's happening, when the requirement comes, then they will have to do the transformation into a Devops organization. So we're just providing the platform and the possibility for them to go that way. Yeah.
Do you have any idea how long time it will take to move all those applications to the new platform?
It has to be done before the end of the first quarter next year, because of an end of support. Thank you.
Okay.